Okay, let's talk algebra tiles. Now, what exactly are algebra tiles? An algebra tile is simply a way of visually representing equations and expressions. So the particular program we're going to look at has three types of algebra tiles, and these are generally what you're going to see. They've got these single blocks. Okay, they might be cubes depending on what your set of algebra tiles look like. If you're thinking in terms of those elementary school blocks, where they had the ones, the tens, and the hundreds, this one, the unit blocks, would just be a ones block. The X would be represented by those 10 blocks, okay, or those sticks with the tens in them, whereas the X squared would be that 100 block. And what we're going to look at is a series of problems. Oh, I forgot already. And the link, I'll post the link on Blackboard. But the series of problems, this is Illuminations. It's a resource for teaching math. It's partnered up with NCTM. Verizon helps put it out there. But it's a series of problems, and it's a virtual way to manipulate some algebra tiles. So even if you don't have the actual algebra tiles that each of your students can have in the classroom, you can take them to a computer lab and have them do some problems, post a link on a website, let them work one-on-one, or even as a whole class, model these problems. So here we go. We're going to start off by modeling the equation x plus 4 equals negative 5. So I'm going to drag my tens block over, and then I need 4 of these ones blocks. Okay, so again, I just drag those over. Now, I can use this button here, and it's basically going to like clone each of these blocks. So I now have 4 of them. Now I need to switch these ones blocks from being positive to negative, and that's what this button's going to do here. It's going to switch those. Notice they went from being like green or yellow to now they're red. And again, I'm just going to use this button here. So I now have cloned out, and I have 5. So I now have the equation x plus 4 equals negative 5, and note the directions here told me to solve this equation. So first of all, it asked me to build my model. I now have a model, and as a student, if you put them on the computer and ask them to do this by themselves, you've got a whole class of them, the first thing the kids are going to ask is mine right? And you can't go around and individually check each and every one of them as they're going. However, you can have them click that little check mark there, and because it's right, it's going to open this up and say, now, okay, solve for x. So now here's what we need to do. We need to get rid of all of these blocks and actually get this x by itself. So in order to do that, I'm going to move these to the other side. Well, if they get moved to the other side, then now they're negative. So that's why I changed the color and change them from being positive and negative, because I'm literally subtracting 4. Okay, well, now I've got my equation, so now I've got x, and now I've got negative 9. So I can type that answer in, and it tells me that it's right. I can hit this little icon here, it looks like a new page, and it's going to give me a new problem. So I've got now negative x plus 1 equals 1. Great. So I need a 1 here, and 1 there. And I need a negative x. I'm going to check and make sure I got it set up right. Yep. Now I need to move this to the other side. Well, this time I'm going to move it to the other side, and as soon as it crosses this line here, it becomes negative. So now I have a positive and a negative. Well, a positive and a negative cancel each other out. So I can use the button up there, just like I just did, to cancel out a positive and a negative. Now, so it equals 0, you can see here. I'm going to put my check mark. Oh, but it's not right. Why? Why isn't it right? Well, remember this x over here is actually a negative x. And we're not solving for negative x, we're solving for x. So the last thing we need to do is go through and change that sign so it's now positive x equal to 0, and now we're good. Now, there are other options here. That was just solve, which is perhaps the most basic one. You'd probably do that with maybe 7th or 8th graders as they're learning to solve equations. You could do it with your Algebra 1 students as they're working. You know, some of these problems are definitely more complex. Some of them are a little bit easier. So it's definitely a good system, a good opportunity for students to practice and get some of that hands-on work. Now, one thing you could have them do as they're working is, you know, maybe they're going to start with this, and maybe they're going to solve it using these algebra tiles. Maybe you're going to have them also work the problem and set up the steps on their on a sheet of paper to turn into you when they're done. Substitution. You could practice that here. I'm going to move on, though, to this expand option. So, how can I expand x times x minus 1? Well, I'm going to take this x here, and I'm literally going to make kind of 2 rows. So it's almost like an old-fashioned multiplication table. So I've got something going across the top. That's going to be my x. Now I need the x's to go this way, so I need them to go long ways instead of short ways. This little button here is going to flip the sides. So now I have them going in a different direction. So I need x minus 1. Now you're going, okay, so it's a multiplication table. So remember with your multiplication tables, what happens? Our model's good. Now remember, what happens is we literally multiply these things together. It's like an area model, if you've heard of those before. Okay? If you don't, it kind of works like this. So there's my my area model, and let's say I've got this part here that's 5, this is 2, 3, and 1. Well, if I want to find the area of the whole thing, I could multiply each of these numbers together. These are lengths of each of the sides. So I've got 5 times 3, so that's 15 is the area for that square. 2 times 3 is 6. That's that square. 5 times 1 is 5. Oops. And then I've got 2 times 1, and that's just 2. So that would be the area of each of those little boxes. Now, to find the area of the whole thing, I'm just going to add them up. So I could have 15 plus 6 plus 5 plus 2 equals 28. And that would be the area of the whole thing. Or, remember, you could have added 3 and 1 together. That's 4. 5 and 2 together is 7. Multiplied those. 4 times 7 is still at 28. Kind of looks like this here. So here's the deal. Remember, we know that x times x, you should know if your students are trying to do this, and they should know that x times x is x squared. So this x squared down here suddenly becomes available. Now, so I've got an x times an x giving us an x squared, and I've got an x times a negative 1. So that's going to give us a negative x. Now, our model is good, so now we have to write it out. So I'm going to have an x squared minus an x. And I can check it just like I could before. I would say that solve is your basic level, and this expand is definitely something higher level. If students can't solve, then they probably are going to have trouble expanding. The same thing, you're going to want to have an opportunity to maybe practice some properties of exponents, or maybe you're going to use this to introduce properties of exponents. It's also a great visual tool for your students, and especially the ones that are visual learners. Of course, after you've expanded, the next thing you're going to want to do is learn to factor. So undoing, expanding, undoing that distributive property. And again, just like before, there's multiple problems here, so you could have negative 3x times negative 3x. This time, let's see, something like this. So this time we've got 2x squared. So I'm going to go ahead and get our x squareds set up. Then we've got 15x plus a 7. So I'm going to go ahead and get this set up. Okay, so obviously I paused the video here and rearranged things. The reason I wanted to show you a different type of problem here where it had a middle term is because when you use algebra tiles to either multiply or expand or factor, it should always look like a rectangle. It should represent that area model I referred to earlier. So notice that I rearranged the tiles so we could have a rectangle, and that can be sometimes difficult until students get the hang of it. Note that all of my ones units are together, all of my squared units are together, and then I've got kind of two separate units down here, are groups of the tens units, or those x units. So once you get it put together though into a rectangle or a square, it makes it a lot easier for students to actually be able to multiply things. So take a look here. If we try and figure out what would go across the top, well, in order to get an x squared, I'm going to need an x plus another x, or in this case, I'm going to need two x's in order to get 2x squared. And then how am I going to get one unit, one x here, and then 7 down here? 7 ones. Well, I'm going to have just a 1 unit. Again, what could I take to multiply x by in this case and get an x squared? Well, it's going to have to be another x. Okay, check my math. 1 times x, would that give us an x? Yep. So then how are we going to get all of these x's? Well, I already have an x up here, so what am I going to multiply by? In this case, it's going to have to be a 1 in order to get each one of those. So how many am I going to need? Well, I'm going to need the same number of what I have in the rows, which turns out to be 7. And then I can go up here and actually enter my equation in. Now note that it will tell me that I have it factored correctly and that I don't have my expression entered correctly. So then I've got an x plus an x, so that would be a 2x plus 1, closing my parentheses, opening it back up again, and I've got an x plus a 7. I think an activity like this is really good for students because from what we've seen as far as PARCC goes, their input is going to look a lot like this. They're going to have maybe some of these activities where they're going to have to drag and drop things and create some sort of area model or algebra tile expression to show somebody how to solve an equation. So that's a quick introduction to algebra tiles. You'll find your assignment posted on Blackboard for what you need to do with it.